All right, let's take a look at some more rational expressions. We just need to get some common denominators here and combine them together. So the first step would be probably to factor anything we can. So this x squared plus x minus 6, we could probably factor that. There we go. And let's see here. What two numbers multiply to negative 6 but add to positive 1? So you're probably thinking 3 and 2, that multiplies to 6, and you can subtract and get a positive 1. Just make sure you have the positive and negatives in the right place. So 3 minus 2 is the positive 1, and then everything else looks like it'll stay the same. So you'll notice that two of them already match, which makes this problem a lot shorter and easier. So that just means the right-hand side needs the x plus 3 on the top and bottom. Like that. So same denominator now. So we'll have 1 minus 2x, and we'll have minus 5x, right? Be careful here, it's going to be minus 5 times 3, so minus 15. All over our denominator. And just simplify the variables here. We got negative 2x and negative 5x. And then we also have a 1 minus 15. So let's see here. 1 minus 15 will give us a negative 14. And negative 2x minus 5x is negative 7x. Right, and the bottom just stays the same. And that should be one of these answers. It looks like it is 16, 16, nope, D. Yeah, negative 14. It's okay that these are a different order. That's just fine if you switch these around. Okay, so don't worry too much about the order of things, as long as all the same terms are there. All right, so let's go down to number 12. More common denominators, so looks like this will be a little bit more factoring involved here. So we got to be careful. Let's see here. This is going to be 2x squared minus 7 squared. So those are your two squares. So I know this will factor to 2x plus 7 and 2x minus 7. And we just need to factor this over here. So this looks like, squeeze it in right here. To multiply to 2x squared, we'd have to have a 2x and an x. And to multiply to negative 49, we'll need to have a 7 and negative 7. Now the question is, which gets the negative, which gets the positive, so that we end up with a positive 7. So you can just do some trial and error, something like this. You put a negative and a positive here, and you can see you get these two will give us 14x, and this will give us minus 7x. So that would be the correct order. And remember, we're doing that step. You're multiplying the outsides together and then subtracting the product of the inside. So 14 minus 7, and that gives us 7, so I know this is the correct setup. Okay, and as far as the common denominator goes, we just have to see what they have in common. So looks like they both have this in common, right? So to make a common denominator, I just need to put 2x plus 7 onto here. And then over here would need a x plus 7, right? So that should be our common denominator right there, which is C. Okay, let's go down 13. This time it's division, so just have to flip things around a little bit. So we'll have on top x squared minus 9, that's x squared minus 3 squared, right? So we have x plus 3, x minus 3 there. Difference of squares. Same idea on the bottom, right? This is minus 9, so it's 3 and negative 3. This is minus 25, so we'll have plus 5 and negative 5. Multiply by, factor here. So we're going to have, let's see, a GCF of 5, right? We take a 5 out of there. Actually, a 5x, looks like. Yeah, put that over here. 5x. We'll have x minus 5 left over. There we go. Notice how this is the bottom here, but I flipped it to the top, because whenever you divide, you have to flip the second fraction. So that means the 3x plus 9 will be on the bottom, right? So factor that. You have take out a 3. Divide each of those by 3, you get x plus 3. All right, now we can see what we can cancel. We got x plus 3's that cancel. Got x minus 5's that cancels. Nothing here and nothing here and nothing diagonal here. So it looks like what's left over will be our answer. We could put the 5x in front on top. Right. Then we'll have the x minus 3 here on top. And on the bottom, we'll have a 3 and an x plus 5. So that would be our answer A here. All right, let's do a little solving now. So we're looking for solutions. Now to be very careful because there's also excluded values. So let's talk about those real fast. Excluded values. That's a C. Excluded values. Basically, those are values that if you plug it back in to here, will give you an answer of 0 on the bottom. Because you can't divide by 0. So if this was a 0, if we got an answer of 0, that would not be good because we'd have 3 divided by 0. If we got an answer of negative 3, that would be bad because negative 3 plus 3 is also 0. So from the very beginning, I already know I can't have an answers of negative 3 and 0. Right? Those are not allowed. So that leads me to believe, since a lot of these are negative 3's and 0's, that we might have a no solution if that does come out to be the numbers that come out of the equation. There's a positive 3's here, so that might be a possibility, but still 0 is not likely. So we might end up with no solution just because of that alone. Let's look at the common denominator. We can do a little factoring here. You can see that the right-hand side is denominator. It's just a product of these two, right? An x plus 3 and an x. So a good idea for these types of problems is to clear the fractions out completely. Multiply by the common denominator by each and every term. So that's, 1, 2, and then even over here. 3 times, just multiply it by, and you'll see things cancel out. Here's what you do. You see how we're going to multiply all of this together, right? But there's an x on the top and x on the bottom. So the x will cancel out, and we won't have a fraction anymore. And it'd be left with the 3 and the x plus 3. So we'll be left with 3 and x plus 3. And then just repeat the process, right? You can see here with here, the x plus 3's will cancel out. It'll be left with 4x, which is a minus. So minus 4x. And then lastly, there it is. Right here with this, you can see, I guess that'd be here too, that the entire denominator will cancel out. You'll just be left with a 12. So equals 12. And then we have a, looks like a linear equation, so that's nice. Not a quadratic or anything. A little bit faster and easier to solve. equals 12. We'll combine these two variables here, so we'll get negative x plus 9 is 12. And then subtract 9 on both sides. We got negative x equals 3. And you can divide both sides by negative. And we got x equals negative 3, right? So the answer must be C. Is that correct? No, because that's on our excluded value list right here. We had an answer of negative 3 and plugged it back in right here. We have negative 3 plus 3, which is 0, and you cannot divide by 0. So that answer is out, right? And we're sticking with no solution because we had to throw this number out. Let's go over to the next column, to number 15. All right, which polynomial has functions? Which polynomial function has zeros of 1, 1 plus I, and 1 minus I? So let's find this equation here that has these three roots. So we know it's going to be a cubic, as you can see here. And we have to multiply a real root, which is 1, which we'll write as multiply together as x minus 1. Right? And then we have these two complex roots. So we have to multiply those together carefully, and as x minus 1 plus I, and then x minus 1 minus I. Squeeze that in there. So that's a little more tricky right here to multiply those two together. Let me focus more on those first. What I'm going to do is actually regroup these. The x minus 1's together. Okay, so I can write it as x minus 1, right, plus I. That's its one term. And then we have another one of x minus 1, right, and then minus I. There we go. So this way, it's a little bit easier. It kind of looks like a difference of squares. So off to the side here, you might notice like when we have like the x plus 3, x minus 3, it's the same format here. So we usually multiply, these two together, right? And they're the same thing, so it becomes x squared. Well, same thing here. We have an x minus 1 times an x minus 1, so it's just x minus 1 squared, right? And then likely we have positive 3 times negative 3, which gives us negative 9. So we have a minus for sure. And then here it's I times I, which is I squared. And if we expand this a little bit, x minus 1 times x minus 1. Put that up here. X minus 1 times x minus 1. We'll get, let's see here, x squared, right? And then minus x again. And then negative 1 times negative 1 is positive 1. So this actually becomes x squared minus 2x plus 1. But then we have this minus I squared. And you might recall that I squared equals positive 1. Oh, sorry, equals negative 1. So this is going to be minus a negative 1. So after all that, we finally find out that the polynomial that has roots of 1 plus I and 1 minus I is going to be x squared minus 2x plus 2. And then we're still not even done. We still have to multiply this x minus 1 times everything. So we have to do x minus 1 times our polynomial here. So we'll have x cubed. Okay. We'll have minus 2x squared and then plus 2x. Then we'll have minus x squared and plus 2x and minus 2. We start combining like terms here. We have some x squareds, So that looks like it's going to be negative x squared and negative 2x squared will give us a negative 3x squared, right? Right here. And then we have 2x plus 2x, which will give us the 4x. And then, of course, on the ends, we have the x to the third and the minus 2. Yeah, so we get an answer of C. Might need to practice this one a few times. That's a little bit of work you got to make sure you know how to do. All right, let's find a solution set to this. So we should have, since it's a fifth degree, that's the highest exponent here, we should have 5 answers. All right, we could have some double roots, so that's how we could possibly have 3 or maybe even 2, but this answer here that has 5 different answers is not out of the question. So let's get this equal to 0. That's always a good idea, right? Subtract the 18x to the third on both sides. We'll have, plus 7x to the fourth minus 18x to the third, since we subtracted on both sides. That equals 0. These all have at least an x to the third in common, so I can take an x to the third out there. We'll have x squared plus 7x minus 18 equals 0. And finally, this factors to see what multiplies the negative 18 adds the positive 9. That'd be 9 and 2. Right? Positive 9, negative 2. So it looks like my roots are from x to the third equals 0. Right? What times itself 3 times gives you 0. That would be 0. Right? Then we'll have x plus 9 equals 0. What plus 9 gives you 0? And that would be negative 9. And then lastly, what minus 2 gives us 0, and that will give us positive 2. So we have 3 solutions here, 3 unique solutions of 0, negative 9, and 2. So we have 0, negative 9, and 2. That would be choice C. For number 17, first I can see that each of those coefficients has a factor of 2 in it. So the first thing I'm going to do is actually divide out negative 2, or factor out a negative 2. That'll make these numbers a little bit easier to work with. So we'll have x cubed, right? Yeah. And then we'll have plus 4x squared, and then we'll have a minus 3x, and then we'll have a minus 18. And then we have to figure out what one of the roots are here. We can possibly do this by grouping, but I think if I factor out x squared, I'll be left with x plus 4. If I factor out a negative 3 here, I'll be left with x plus 6. So the factor by grouping won't work. So we'll just have to pick a number and test it to see if it works. So look at your possible answers here and see if anything is in common with all of them. That way we don't waste our time. So there's a negative 3, negative 3. This doesn't have a negative 3. That does. But looking at these answers, they all have, I think, a positive 2 in it. So that's a good hint that you can use. That let's figure out what we just use synthetic division and use 2 as our factor. Let's see what's left over. That'll give us a hint of what we should be doing here. So 2 times 1 gives us 2, 6. 2 times 6 is 12. 12 minus 3 is 9. And then 2 times 9, which is positive 18. There's the answer. So we have an x squared plus 6x plus 9. And if you factor that down, what factors to x squared, x and x, what factors to 9, that would be 3 and 3, which also happen to add to 6. So we have a multiplicity of 3 and of negative 3. Yeah, so we have an answer of x equals -3, right? And then we also have an answer of 2. So that's answer D. 2 with -3 with multiplicity of 2. All right, let's go on to the next. So we need to find a third degree polynomial with -3 and 2 as its only zeros. So third degree polynomial means, looking at these answers, that looks like A is out because that's a second degree polynomial. Can't have that. So next thing you might notice is that, well, how can you have 3-degree polynomial but with only 2 zeros? So the only possibility is that, like the last problem, one of these must repeat. So we're going to start just by multiplying these together as factors. So -3, 0 will be a factor of x plus 3. +2, 0 will be a factor of x minus 2. And just multiply those together. So we'll have x squared, let's see here, 3 minus 2 is 1, plus x, and then minus 6, right? And then you just have to take a guess. It's going to be one of the two, right? So let's just multiply it again by another x plus 3 as if that was the repeating root. And we have to multiply them together one more time. So we'll have x cubed, right? And then we'll have x squared, and then minus 6x. All right, and then do the other side here. So we'll have, see, 3 times all these, right? So 3 times x squared, that's plus 3x squared. And then 3 times x, that's plus 3x. And then 3 times -6, which is -18. All right, so just on the first and last term alone, x to the third and -18, it looks like my answer is C. But I want to make sure I still get these two in the middle. So those two are pretty solid. And then when I add this up, 3 plus 1 is 4x squared. And -6 plus 3 is minus 3x. So that does match up. So we could have got a different answer that wasn't here if we tried to multiply by x minus 2 instead, and then just had to go back and try the other root. All right, let's go down to number 19. For this, we use a rule called the Descartes law of signs, which lets us know just how many possible roots there could be. It's not something we actually covered during the semester. These days, it's easier just to graph it and see. But if you're interested, what we do is really look at how many times the sign changes from positive to negative in two different ways. For the regular way, like when it's just f of x, so it goes from positive to negative, that's 1, negative to positive, that's 2, and then positive to negative again. So it has 3 sign changes. So for the positive, we have 3 sign changes, which also means since these things come in pairs, it could be 3 or 1 possible, or 1, right? And we do another thing where we basically switch the sign of the odd exponents, right? And see how many sign changes there are after we switch the odd exponents. So let's say this changed to negative because it's an exponent of 3, and this changed to a negative because it's an exponent of 1. You can see they're all negative now. Now, because of that fact, it lets us know that there are no possible negative answers, so we're going to have to end up with only one possible real root for some other reasons. So I said we didn't really cover this, but that's the meaning behind it. So don't worry too much about it, just an extra piece of information. So let's look at number 20, and then we can end up there. So which of is a list of all the roots? Okay, so basically factor this and solve this all the way. So we got a third degree, got 3 roots, and let's try this by grouping. I think grouping will work really good. So let's factor those two, like take out an x squared, we'll have x plus 1, and then factor just a 1 from the second two terms. That'd be x plus 1 as well, right? So we have x squared plus 1, and then x plus 1. So we can see from here that, yeah, x equals -1 is a root, so since a is the only one with a -1 here, that's probably it. Both of them have negative I and positive I here, and that comes from solving this, right, equal to 0. So if you subtract 1 on both sides, you get x squared equals -1, and square root both sides, square root of -1, that's how you get the plus or minus I. Let's see here. All right, let's just do one more here. Let's do 21 because it's another question that has to do with roots. So let's go ahead and solve this. So we can get this equal to 0. That'd probably be helpful first. So we have the x cubed, that's fine. Let's move this 3x squared over to the left. So that's going to be a negative 3x squared. And then we have 3x. And then we have minus 9 if we move that to the other side. So that's the first step, is get it equal to 0. And then it looks like with the 3's and 9's, we could do this by grouping as well. So let's take out an x squared from the first two terms. We'll have x minus 3. And then let's see here, we can factor out a 3 here. So we'll have x minus 3 as well. So it looks like the grouping worked this time. So we have two terms, or two factors, x squared plus 3, and then x minus 3 equals 0. So with x minus 3 equals 0, we just get an answer of positive 3. All right, so it looks like all these have that listed. That doesn't help us. So the next one will have x squared plus 3 equals 0. So x squared equals negative 3. And then like the last one, which is square root both sides here, all right, we'll get plus or minus root 3, right? But since we took the square root of negative, we also have the I. So basically, you get the same answer you normally would, but because there's a negative inside, we have the I as well. So that will leave us with an answer of, let's see, 3 comma plus or minus 3I. That would be C.